Good morning, this is your Stat Sensei, Mr. Spensei, and this is a warm-up for the paired t-test. So Professor Andy McNeil measured the time in seconds required to catch a following meter stick for 12 randomly selected students. That's going to be important. First off, it's randomly selected. That's one of our conditions. And now we know our sample size is 12. Dominant hand and non-dominant. So we recorded it twice. And because we recorded it twice for the same person, we can look at our table and go, hey, student one got recorded time for dominant and non-dominant. Because it was something done twice, the same student was measured twice. That makes it a paired test, a paired test. If we had a separate group, one group that was non-dominant and another group that was dominant, that's not paired. But since each one was tested twice, that's a paired. McNeil claimed that the reaction time in an individual's dominant hand is less than the reaction time in their non-dominant. Professor Neal has 220 students. All right, so that looks like the population size. The difference in reaction times are normally distributed. We need to know that. So that's condition 3 right there. And alpha equals 5%. Is the dominant hand faster, dominant minus non-dominant? Now, please remember, if it's faster, that means maybe it takes 10 seconds here and maybe it's 11 seconds here. So this means we're looking for a less than situation, which is what they indicated here. All right, that's what was indicated there. So our formula, well, please remember, it's very similar to the T. As I've stated before in the other videos, T equals X bar minus mu S divided by square root of N. But now we are talking about the differences. So we're going to have to subtract these two data values and take the average. All right. Mu D is very tricky for this. And the assumption is that there is no difference. The assumption is equality. And if this hand and this hand are the same in speed, then we'd expect that to be zero. So this will always be zero. Please remember, n is the number of pairs. All right, the number of pairs. So in this case, we have 12 pairs. All right, we have 12 students that were tested twice. We don't say that there's 24, our number of pairs is 12. All right, so with that said, we need to go ahead and enter that information into our calculator. And I've gone to stat edit and I've already done that. So they're all, so here's my information all in stat edit. But I don't need just the data values, I need the differences. To do that, I'm going to go blue 1 minus blue 2, and there's my values all listed. Okay, so there's my differences. Some are negative, some are positive. If they're negative, it means it's faster. If they're positive, they're slower. And I'm going to do a stat calc one var stats and make sure that you have your L3 because that's where the differences are. We don't really care about the dominant hand. We're looking for the differences. And there it is. There's my sample mean, negative 0.013. So it looks like it's a little bit faster on average. And there's my standard deviation. So we're going to go ahead and record that. And as I said before, we're assuming that there is no difference. So there's no difference in time. We ended up getting a sample difference of negative 0.0131 and a sample standard deviation of 0.0164, and we had 12 pairs of data. We're going to be running a one sample paired t-test, and this is all we really need to see, one sample paired t-test. And please remember, when we're drawing this, all paired tests are centered on the mean. Well, all hypothesis tests are centered on the mean. In this case, our mean is 0, and our standard and our sample mean is a little bit lower, and we're going to be shading to the left because they said less than. So we have a shade to the left, and this right here is going to be a less than situation. All right, we're going to go ahead and plug into this formula, 0 from MD, negative 0.0131 for the X bar, our sample standard deviation 0.0164, and then, of course, the number of pairs, which is going to be our sample size of 12. Next thing we need to do is go ahead and write our hypothesis. Well, our hypothesis is we assume that the time is zero, that there is no difference. So HO mu D equals zero. And please remember, all null hypotheses for this class will always be equal. And in this case, when we're working with a paired, this is true for all paired. There is no difference. The alternative will have exactly the same, look exactly the same with the exception of the inequality. The inequality is a less than, and that inequality came from right here and up here where it said less than. Now, one thing to always remember is you've got to include the D's. So make sure you do mu D, okay? So let's go ahead and run this test. Oh, and by the way, this is just saying, hey, if the dominant hand took 17 seconds and we know it's going to be faster, that means it's going to take less time. So we randomly picked a number that was larger than that. And we go, oh, that helps me set my inequality where it goes. So stat test, and this runs just like a one sample t-test. We go to t. We have data. Our mean, we claim to be zero, claim to be no difference. But the differences are in L3, so blue 3. And we wanted a less than, and we calculate, and we end up getting the probability that t is less than negative 2.7759, and that equals a p-value of 0.0090. So this is the way you would write that, okay? And it makes sense that we'd have a negative t-score because we're below the mean. Our sample's below the mean. So they gave us an alpha originally of 5% up here. So there's my alpha of 5%. And when we compare our p-value to our p-value is definitely less than our alpha. So our decision would be to reject the null. Every time the p-value is low, the hoe must go. All right? We have to reject the null hypothesis. All right. Creating a 97% confidence interval for the same thing is what it asks us to do next. All right, so let's go ahead and highlight 97%. Our formula is just like the regular t interval formula, x bar plus or minus t star s divided by square root of n, but we need to drop some d's on it, and they occur here. We have our sample mean, our sample standard deviation, and our number of pairs. All right, so let's go ahead and calculate our t star, and you can already see that I have it up. To do that, you're going to go second vars inverse t, parenthesis 1 minus 0.97, close the parenthesis and divide by 2. Degrees of freedom is going to be the sample size minus 1, so 12 minus 1. Please don't forget that is true for all one sample tests, so n minus 1. And we end up getting a t star of 2.4906. I know it shows negative here, but we're positive people, so please always make this a positive. So even though you got a negative, go ahead and make it a positive. All right, we need to go ahead and calculate our values. And we're going to go, well, stat, test, and drop down to, stat calc, one var stat. Our differences, now I should go back and go stat edit. Originally, I put all this data in L1 and L2, and then I went up to top of L3, and I went blue 1 minus blue 2. That gives me L1 minus L2. That gives me those differences. And I went stat calc, one var stats. My data list that I care about is an L3. That's the differences. And these are my values. All right. Now, I had previously listed them, and we already talked about the degrees of freedom having the formula n minus 1. All right. And we have 12 pairs of data. So I'm going to go ahead and plug all that information into my formula. So X bar D is where I start, and that's at negative 0.0131. My T star is 2.4906, and that just comes from right above. And then we have our sample standard deviation of 0.0164 divided by the square root of n, the square root of the number of pairs. All right, to draw this, please remember hypothesis tests are always centered on mu, but confidence intervals are always centered on x bar. So this confidence interval is going to be centered on x bar, so it's going to be centered on negative 0.0131, and we're supposed to have 97%. We'll have a lower and an upper. As you can see, we're running a one sample paired t interval. Please make sure you have all this information that's been highlighted. And we're going to go to the calculator and we're going to run a t interval. So stat test t interval. We have data because we put all our data, all of our differences in L3. We need to make sure that we have L3. If you don't, press blue 3. And we wanted a 0.97 confidence level. And we end up getting a negative 0.0025 to negative 0.0014. All right, so this is my lower bound, and this is my upper bound. Well, if I went DOM minus non-DOM, this means this one has to be less. And so if I could say, oh, it took 10 seconds, and here I said it took 15 seconds, I end up with negative values. The fact that both are negative values and zero is not contained indicates that the dominant hand is actually faster than the non-dominant. All right, this is the end of the warm up, and I appreciate you watching and hope to see you on the next one. Thank you.